Hi, welcome back. This is part three of our network automation with Red Hat Ansible. So in the first couple of videos, we highlighted more about how DevOps and cloud work together, and also about how important automation is to everything else that you do. In this video, we'll highlight a little bit more on the developer self-service that we've talked about just in general with becoming cloud native, and just what it means to have infrastructure teams lay a foundation for automation that developers can run very quickly on and do what they do best, which is innovate. So in terms of looking at a code level and how Ansible really works, just the basic picture is we use Ansible in the first place, and we have generally repos that are split. We have permissions to some of those as developers. We don't have permissions to others. And so subject matter experts are able to create a base for Ansible that would configure things like an operating system for instances, do anything around common configs like NTP, DNS, what have you. And then we can work and commit changes to a self-service repo that would let us make changes to things like Nginx, load balancers, et cetera. Um, so very nice that we can somewhat divide and conquer in how we're going about achieving our overall automation goals. So coming back to this slide, the two things that we want to highlight in this video are, first of all, the module support, and secondly, just really talking about the opportunity ahead and the art of the possible. So with network modules, you'll find if you take a look at the list on Ansible.com, you'll find dozens of network OEMs and well over 1,000 supported network modules today. And one of the things, kind of looking at big picture, is that working with something like Ansible, as opposed to working with native cloud provider services or native OEM provided frameworks, does allow us to avoid lock-in, whether that's cloud or in the data center. And that's certainly very important. And I think the more that we look at multi-cloud, we look at hybrid cloud, and anything else that really is about, continuing to scale our infrastructure, scale our applications, and so forth. We want to look for any opportunity that we can to have freedom of movement going forward. So we'll jump out of the slide deck here, and we'll go in just a little bit, and we'll look at some basic load balancer playbooks. So I'm taking most of this code directly from Ansible.com, and we're not really going to do anything super fancy with it here, but I just want to talk a little bit just in the general case about simplistically, like how we would take different code and combine it into our own idea of a base. So for something like Nexus switch, all we really have to do here to build a base is to go ahead and put these together, right? So if we want to configure like an MOTD banner or something like that, we want to configure, some type of console logging, we can include that as a part of what we're doing here. And the only reason why I'm really highlighting, this is just to show, if you're a developer, one of the reasons why the infrastructure teams might be looking at Ansible as opposed to, something else, because it really is so easy to mix and match here and just combine, well defined, well supported code examples by OEMs and by the community, and put this all together into a single playbook here. And once again, this is a very simplistic case, right? We're just doing this for the purposes of a short video here. But this is how easy it is for us to define if we care about things like disabling OSPF and that routing protocol or anything else on a Nexus, in a Nexus environment. We're able to do that and able to do other things, very simply. And obviously, this just goes back to the kind of version controllable nature of working with Ansible and frameworks like it. And then in terms of working with a VIP, so this would be more going back to the kind of self-service aspect of this. Our developers would be in a position, oftentimes they do care about load balancing more than they care about a lot of the infrastructure details that I was just highlighting. But in terms of being able to work with something like Ansible, this would be a case where maybe, something about the basic NetScaler OS, which is FreeBSD based OS, maybe some aspects of that would be managed by the infrastructure teams, but maybe the OS version itself and things like that. But in terms of building VIPs or managing those VIPs, that's something that typically app devs are more involved in. And so this is just a quick look at a simple set of a simple task and how it would actually configure a vServer and bind it to services. So once again, if we think about AWS and we're trying to draw equivalence inside of our data center, we're able to do through code now the same kind of things that we would be doing with an ELB or an ALB here on a NetScaler sitting in a data center. So, coming back into the presentation, just to sort of wrap up on this, the the real opportunity that we have here, and when we look at Gartner studies, and this applies to pretty much any audience that we would have a discussion about with regard to network automation. If only about 10% of network devices have been automated so far, then anything that we start doing on our network devices makes us, better than 90% of the folks that are out there, and that's pretty great. And it certainly puts us on the path to becoming truly cloud native. So just to recap this sequence, networks, pretty much the final frontier of infrastructure code. Ansible's design doesn't require us to install anything on our network devices to get started and doing really good things with it. Yes, Ansible absolutely integrates with that, and you can start using Ansible in your environment literally in minutes right now, today. And the final point, and that we've been making really throughout this video series so far, is that becoming cloud native really means using the same tools in your data center and in the cloud, and Ansible can help. Thank you so much.